Hello everyone, welcome to Battlesnake Coding Badly. My name is Joe, I am your host for the day. Hi Penelope, hi Brian, thank you so much for joining us today. If you are new here, Battlesnake is a programming game where you write the AI to control a little snake that doodles around and eats your opponent's snakes, and Coding Badly is the show where we lower the barrier to entry to Battlesnake by doing really ridiculous stuff. But this is actually the last Coding Badly show of the year, and as is our tradition here on Coding Badly, we bookend the season by inviting people who actually know what they're doing and have done something really cool. We started the season with Penelope, who is in chat, writing a bash snake, which left me and my co-host Kevin just essentially brain dead for an hour. We were wrecked, absolutely had no idea what was happening. And today we've got a very special guest who's going to be showing us a really the best API mashup snake one could ask for. So that's very exciting. Before I bring on our guest and we get into the snake of the day, couple of usual announcements, a little bit of housekeeping. First up, a huge thank you to our partners, RBC, AWS, and GitHub. They make it possible to do what we do. If you enjoy what we do and you enjoy Battlesnake, you enjoy watching Battlesnake here on Twitch, make sure to let them know and give them a big thank you for being a part of it. And of course, the other thing to shout out is the Winter Classic is fast upon us. The Winter Classic is a different format this year to last year. It's an invitational where the biggest and baddest Battlesnakes have been invited to a special tournament for the top achievers, Brad's Special Snakes, to fight it out. For this league, usually we run a kind of open arena and then you qualify to go through to the tournament. This invitational has reasonable prize money against it. We're really esports now. And the first of those tournaments for the Platinum Snakes is actually this weekend. It is Saturday, so make sure you tune in to the first ever Battlesnake Winter Classic Invitational. Penelope, who is an invitee, says, I identify as a medium achiever. That is definitely not true. All the snakes involved are titans of Battlesnake, folks. Absolute titans. So that is this Saturday. Snake Pit Live will be happening at a time. I'm sure it's on the event tab on the Battlesnake website, but as usual, I don't know what's going on. But for now, let me bring on our wonderful guest of the day. Please welcome Chuck. Hey Chuck, how you doing?
Hey Joe, how are you?
I am wonderful. Thank you so much for joining us today. Where are you joining us from?
I am joining you from Columbus, Ohio, here in the United States. Columbus is right in the center of the state, so it's a 2-hour drive to get anywhere else from here.
Perfect. That's the level of isolation I want in this current global circumstance. Tell us a little bit about yourself. Introduce yourself to the audience.
Sure. So I am a developer relations engineer, senior developer relations engineer at Algolia. And it's a position that I've been in just for a few months now, and I'm really kind of getting my feet wet and really kind of enjoying it. Been a few other places over the years. I was at Amazon for a little while at AWS, which was fun. Any place I go, I kind of always like to go in and start seeing like what I can do, rolling up my sleeves and building some stuff. And this was a great opportunity to build some stuff.
I hadn't realized that timeline. So if you've been at Algolia a few months, like when did you build Searchy? Did you build Searchy before you joined Algolia, or like literally the first week?
It was kind of one of the first things I did. You know, I was like, what can you do with this API? And so I was starting to play around with it, and this seemed like a really fun way to kick the tires, right? I think that's probably something you get a lot of, right? Is like, I've been looking for an excuse to use this technology, and now I have it. Right?
Yeah, perfect. So I really jumped the gun there because I was so excited by that. I hadn't realized the timeline was so close. Searchy, tell us about Searchy. Tell us about your snake.
Absolutely. So as I kind of spoiled right there, I work for Algolia, and our sort of business is API-driven search for your website. Right. And I thought, I've got access to like this super fast search index. Like, how could I wire that into a snake? Like, is there a way where it is legitimate to have a snake that makes its decisions based on a search?
Right. And I hope the answer to that question is it is legitimate, right?
Spoiler alert.
There was a way.
It is actually legitimate. Searchy is a live snake that is out in your arenas right now, picking up some wins and losses. And yeah, it's actually working. So
Let me see if I can pull it up on the arena quickly. Sorry, I didn't have my screen. You know, I'm just stunningly unprofessional. I didn't have my screen share prepared.
no
One
problem.
moment.
Well, I have
You've
Mr.
got it up?
Searchy up here too, if you want to.
It's Searchy. Perfect.
Oh wait, this isn't actually Searchy. This is
this
someone
is
else.
soon to be Searchy's sibling.
Searchy's sibling. Let's get to Searchy here. Here is Searchy.
So Searchy is in all of the arenas: Global Duels, Global Arena.
Yeah,
and Global
I
Royale.
figured why not? We'll let Searchy
Yeah.
run everywhere. And she's sitting just over 300 in the global
Excellent.
arena,
Excellent.
which is doing good there. And I think she's got about, it was like a 24 and change % win rate last time I looked.
It's very respectable. I mean, one of those in Duels, it was gold. Or she was gold.
Mm-hmm.
Perfect.
So let's see here. Yeah, so Searchy's sitting just over 25% right now.
I'm noticing we need an Algolia tag.
Oh my gosh, that would be amazing if we started to have a little squad of search-driven snakes. I think that would be fantastic. So yeah, so Searchy does pretty well.
Awesome.
If I had to build Searchy a dating profile, I would say that Searchy is hungry, so she's always looking for food. She's
Right.
shy, so
Okay.
she does her best to avoid other snakes. And she's kind of lazy. If she doesn't have anything better to do, she's going to just keep going the way she's going. So,
Perfect.
and we'll see that as we
Perfect.
get into the code.
That's a sound snake strategy. So, speaking of getting to the code, I wanted to ask you how Searchy worked, but I believe this was also explained for your wonderful README, so I guess that would be a good companion to this. But so the approach you found that is legitimate, tell us a little bit about that. Like, how are you using the search index?
Absolutely. So I was thinking about, well, what are different ways that you could actually like have something that's indexed?
Yeah.
And I started thinking about old school chess programs, right? So we're talking going back to like the 70s, the 60s and 70s, and sort of how, chess programs were built back then. How you probably built a chess program if you ever had to do it during a computer science class, right? And
Right.
historically that was done via move trees, right? You would build these min-max trees where essentially you would start from ground, you'd start from an initial board, and then you would imagine all of the different move combinations, and then use those to sort of decide what your best move would be.
Yep. And this would be sounding very familiar to a lot of Battlesnake players who use very similar approaches.
And so, of course, as you think about Battlesnake, there's not really an initial board position,
Right.
and you really only have one piece, and so
Right.
you're really mostly concerned about what's going around the piece itself.
Yeah.
So I started thinking about, well, what could I do to sort of start building out like an index of different combinations? And initially it's like, well, could you do the whole board, right? And then I realized that each square, it's typically an 11 by 11 board, right? Each square has like
that's the
4
default one.
states, because it could either be a snake or a food or empty or the edge. And so, like, as I started running that math, the number that was sitting in front of the E was a little frightening, and then the number that was after the E was even more frightening. So I thought, okay, well, how do I simplify things? And I thought, the first thing you can do is simplify the number of states. And so that's why I decided to make Searchy very focused on food, because then it becomes binary, right? Now you're just talking about, is it an empty square or is it a food square? And then even that was a significant number. I think what it's like, you're in the quadrillions of different combinations still. So I thought, well, to further limit it, let's just limit Searchy's vision. And I started with a 3 by 3 square with Searchy's head in the middle, and then realized that that's only like 256 combinations.
Right.
So super manageable. And then if you take that up to a 5 by 5 square, it becomes like, I think it's like 32 million combinations, which starts to become like less manageable but more interesting, right? Because I can handle 256, but 32 million.
And a 3 by 3 square, like, is that centered on like a snake's head, for example?
Right. So that would be like one square in every direction.
Right. So yeah, if there's a snake, if there's another snake's head in that, you don't really have any room to avoid them.
Right.
Yeah. But 5 by 5 is useful.
5 by 5 is more useful. And actually you can remove the middle square because it's always the snake's head, which means that you actually have your number of choices. So it's actually only like 16 million.
Only 16 million. Modest figure.
Right. So that's kind of where I got to, is I thought, well, that's something I can play with. What
Right.
if we essentially give Searchy radar with
Mhm.
knowledge about different combinations of food. I was calling them apples as I was kind of coding.
Yeah.
I don't know if other people have this, but the fact that food is sort of a plural and a singular was really messing me up as I was naming things. And
I
so
never heard that before, but you're totally right.
I started calling them apples,
Yeah.
apples, just because you can have one apple and multiple
Right.
apples. So
Yeah. I mean, I still encourage people to, when they're iterating through their snake body parts, to refer to all of them as necks. So I totally get where you're coming from.
yeah.
I'm a big fan of the for neck in necks loop. Yeah, that definitely makes sense. Okay, so you're building 16-ish million game states, or like representations of game states, and then those just plop go in the index, or
Yeah, that's right. So
yeah.
so essentially, I build out the game states.
Yeah.
A little bit about sort of how Algolia works for folks that might not know. So it is a managed site search. Really, if it was being used appropriately, would be used for real-time interactive text searching.
Right.
So you start typing the word search into, I don't know, Hacker News, and you get an interesting article about building a Battlesnake using.
Is the Hacker News search still powered by Algolia? I know it was.
It is, yeah.
Nice, awesome.
Yeah.
And that definitely makes the context in which I've encountered Algolia has been for documentation sites. I don't know if you still do it, but I know at one point there was a wonderful open source program which I used for a doc site for an open source project.
That's right. Yeah, we run a program called Doc Search. So
Nice.
if you have an open source project and you have documentation associated with it, or a blog associated with it, you write about an open source project, you can come to our Doc Search page and let us know what the site is, where the documentation lives, and we can, once we validate it, we can give you a code, and then we'll essentially crawl and index your documentation for free and give you the access to be able to put a search right there on your page.
It made me look like a right smart ass, because I rocked up one day to the developers dev docs and was like, "Hey, I've added search to this. Here's a lovely Jekyll site with Algolia search on it." I was very, very proud of it. So you've got your search primarily focused on text.
Right. Exactly. So the way it works is, in order to do all of our magic, right, to index your data appropriately, and be able to be super fast in bringing results back, that needs to come up into our managed service. So we have an API for passing information into an index, and that information needs to be in a JSON format.
Right.
And so that's exactly what I do here. Essentially, I build out all the boards, and we can look at this code as we go later.
Yeah.
But we build out all the boards, then I weight them to say, okay, this is actually the best play based on this particular board. Turn all of that into a very, very large JSON document, and then hand that into the Python client that we have, so that we provide you. And the nice thing about that client is, like, yes, it's 16.7 million records, but I don't have to worry about chunking it or fallbacks or anything like that.
Nice.
It handles all of that. It'll take all of the data and just make sure it all gets up into the API.
How long does a ingest of that size take?
It can take a few minutes. It's definitely a go pour yourself a cup of coffee. It's definitely a go pour yourself a cup of coffee and come back situation.
I tend to measure everything on the scale of is this an XKCD sword fight worthy situation? If you've seen that webcomic.
Oh yeah, absolutely.
Yeah,
still compiling.
Barely worth it. Yeah.
Yeah, I mean, you could probably get a good game of foosball in, So, awesome. But it's definitely not the same as generating the boards, which is certainly go out and have a tasty meal, right? And maybe some dessert and come back situation.
Yes, yeah, absolutely. So that's a wonderful overview. So what we are planning to do today, we're gonna build. Well, first of all, I would maybe have a little look at searching and dig into the repo a little bit, and then I believe have a go at taking the Python starter and setting up on Algolia in case people want to try this lunacy out themselves, because this is coding badly, and of course you want to try the lunacy out yourselves. And then the thing that I think a lot of folks will be interested in is your approach to generating the board states, because that is a hot topic, and we're going to dig a little bit into how that journey has evolved. Is that correct?
Yeah, I think that's a good way to handle it today. And we're certainly, just just to spoil things for folks now, if this is what they were hoping for, we're not going to be generating boards live because, again, that is a tasty meal, and I can't afford to take you all out.
The show is only 90 minutes. We
Exactly.
It's already 10 p.m. We can't be here at all. Perfect. All right, let me throw your screen back up. One resource that you very cleverly put live for today that I think is worth us pointing to right now, your blog post. Let me throw that in chat. Which, not to jam it up too much, but I absolutely love it when a guest rocks up to the stream with, I've written a blog post, it's live now for the stream. It's perfect.
Yeah, it's how I spent my morning. Writing a blog post is the best way to refresh yourself on some code that you've written. And I would encourage anyone to do that. If you're going to have to go talk about something live, whether it's at a meetup or just with your friends, writing it down just makes it so much easier.
Awesome. But yeah, if you want to follow along with anything that's been said today, you want a quick reference, this lovely blog post will get you there. And as I said, also, Searchy's README. As I pre-warned you, I do want to go to a README because I do want to in particular call out. This the story at the top is lovely. This is like a very well put together README. We've got a GIF of the game, we've got a whole story of how it all happens. I love the disclaimer of obviously this whole thing is a little silly, but there could be some interest, but it seems eminently practical. But the one thing I did really want to point out here, really appreciated and would highly encourage if anyone is writing a Battlesnake that uses a particular technology, like a SaaS service metered technology, anything in it, is in the prerequisites how you give the parameters for what is possible on the free Algolia tier versus the paid one. That you can use a number of board states equivalent to 3x3, but if you do 5x5, you need a paid account. That is lovely. Really appreciate you doing that, and also think that's a very useful pattern for us to follow as we continue to build out templates that use various services. So thank you very much for doing that.
And we do have a free tier it's about you get 10,000 records and 10,000 searches a month. So obviously 16.7 million is significantly larger than 10,000. But this is also kind of a silly use case as well.
So actually the search is, so you're doing one search per turn though, right?
That's right.
So it's probably quite economical on searches once you've got your records in there.
Oh my gosh, yeah. If you're out there competing in all 3 tournaments, you can go through it fairly quickly. Now, but the other interesting thing you can potentially do, though, is the throttling is per application. So Algolia has this concept of applications. So you could run 3 copies of your snake for the 3 different tournaments.
Applications.
Yeah, exactly.
Interesting. Yeah, yeah, which gets into some fun territory. How would you? So I mean, we were talking before the show about the fact that you're in the Royale arena and it doesn't know about hazards yet. That definitely strikes me as if you were going to build an index that also included hazards, you would definitely do that on not necessarily build those enormous possibility of states into your normal snake.
Oh, right, exactly.
Yeah. Wicked. So, in terms of kicking off next, do you want to start with the Python snake or look a little bit into how Search is working currently?
Why don't we start by quickly building out a search-driven snake? So what I've done,
sounds perfect.
I kind of got ahead a little bit. And I went ahead and set up a new repo.
Okay.
My coding badly snake here, and this is just a you can see here it's just generated directly from the Python base snake.
Perfect.
And then I've got that in Replit, and it's literally just our little your classic randomized snake. The only thing I've really done to this so far is I've added my name in here.
Wonderful.
I haven't even picked the head and tail yet.
What is your go-to head and tail?
I don't necessarily have a go-to. Yeah, I honestly feel like I didn't scroll down last time, so I missed a lot of them. Right?
There's also there's options. Yeah. There's options that you'll unlock over time as well. Yeah.
Oh, that's cool.
Hey, there's Penelope's new Transright Scarf Snake. Shout out to Penelope, who won crowd favorite in the Fall League and thus got their own snake head and has used it to great effect. I think that landed yesterday.
Oh, that's awesome.
Wonderful to see it in the display, Penelope.
Oh, that's super cool. Let's use it. Can we use it?
Yeah, absolutely. Well, I think you can use it. Community, I don't think there's any locks on that.
All right. I'm going to, I've got a VS Code up, but for this, I'm just going to go ahead and do it right here in Replit. If that's okay.
Yeah, of course.
Just make sure this.
We use Replit a whole bunch.
Okay. There we go.
It's actually been a while since I've Replit up on the show.
Okay, let's make sure that gets picked up.
You know,
it's a small change, but
refresh the snake in your Battlesnakes.
Oh, okay. Here we go. Battlesnakes.
Oh, was it not meant to be? Was it not announced yet, Penelope?
Oh, I'm so
It was
sorry.
in the selector. I mean, it was my fault. I literally called it, but it was in the selector. I think it's fine. If you click the settings wheel on the right, there'll be. It's really small. On the that one. If you click refresh.
Yay! I'm sorry, Penelope. I didn't mean to spend to.
Oh, it's okay. It's only the blog post that's gone live. It's in the platform. It's live. It's shipped.
Well, cool. And hey, my Chrome's gonna relaunch in an hour. That's gonna be fun.
Oh, great!
Got it. That's great. Yay!
Thanks,
for
administrator. I'll set the clock for 10:20 for 11:23. 23
Right.
past the next hour. We can celebrate your Chrome restarting.
All right. Well, does Penelope, do you recommend a tail to go with that lovely?
Oh yeah.
head?
Do you have a chosen tail? I know that Penelope Snake uses the rocket tail. There's a rocket tail on Demi-Fem.
Ooh, I'm gonna do this ice skate. I feel like that's nice and seasonal.
The ice skate is controversial
Really? Oh,
because the orientation makes no sense.
That's true. Well, also, I mean, how exactly are you going to use
I know
that
it
in a
can't be like
practical
bent
sense?
like an angle, right? Like.
All right. Well, I don't want to be controversial, so I'm just gonna go. I'm gonna give my snake a cup of coffee because I know I'm gonna need it by the time
Perfect.
we're done today.
Perfect.
Okay, so let's go back over here. We'll add that in. Okay.
So
know.
I don't think I've actually. Sorry, go ahead.
Oh no, it's okay. Go ahead.
I was going to say, I don't think I've actually looked at the Python starter. I assume it works the same as the JavaScript starter, which is it has an array or an object or something of the possible moves with a true or false, and then it's toggling them. Okay.
Yep, that's right. So we could, I mean, just jumping in here real quick.
Yeah.
You can see it's a list of possible moves,
Right.
and then
We check whether we're going to hit a body
Yeah.
and remove them. I think I saw up there.
the neck is in there. So the neck's a
Yeah.
gimme, and then from there
Perfect.
we're just back down to random.
Perfect. Okay.
So-
Awesome. Oh, it's not
so
even
this-
doing wall avoidance yet? Wonderful.
So cool. So what we'll do is we'll go ahead and, if it's all right with you, I have like some very simple boilerplate wall avoidance. I'd like to
Please
just
do.
dig into this. Just
Yes,
because.
I think we've done wall avoidance from scratch maybe 8 times this season of Coding Badly, and managed to mess it up every time. So I'd very much welcome the boilerplate.
Okay, cool. So I'm going to go ahead and just grab this from, actually, oh, see, now I'm already bifurcated. Let me go ahead and commit that.
Cool.
Did you change? I don't
Penelope,
know.
I still have nightmares about the bash snake.
Penelope, is that the correct spelling, Penelope?
Yes, it is.
Oh, Penelope's Thunder. Okay.
We will do bash snake v2. Maybe bash snake. Maybe this is just how we open Coding Badly every season now with bash snake Penelope, just to really set the tone. We have to kick off the season with just like the most Coding Badly thing we possibly can.
So not even ZSH, it's Bash.
No, it was a straight bash, and honestly, it broke me
amazing.
as a person, as a developer. I was in pieces.
I love it. I love it. Okay, so now we're going to go ahead, and I'm just going to go ahead and add in. Doesn't it sometimes feel like, you're doing a cooking program when you do these things? I'm just going to add in my
Here's one I got.
avoid vols function.
Or as a Brit, I would say we're blue Petering it, but I don't know if that's a reference that makes sense to most of the audience. But
Oh, I know. Yeah. I'm familiar with Blue Peter, although I didn't grow up with it. So, and I've also got this little remove move function just so that
Nice.
I'm not trying to remove the same move twice.
makes sense.
I have that in there, so I feel like I got burned by that at some point. Maybe this is overkill and unnecessary.
This is scar tissue, is it? We're not entirely sure when it arrived, but it must have been in response to some trauma.
You want to know how I got this function? So I feel like the double removal of a direction was causing Python some headaches earlier. So
Okay.
so we've got our avoid walls function. All this is doing is it's just detecting the edges and removing the
Right.
direction. Super basic. And
Perfect.
then we'll go ahead and call that. Let's see, we're still in our neck function there. So we'll go ahead and call that right after we avoid our neck. We'll avoid some walls. And I think I give it my head location and the board. Hopefully I'm getting this data structure right. I think that's right. And then my possible
Yeah.
moves, which is just those 4 moves.
Perfect.
Okay, so we're not even getting into search yet. This is just table stakes. I probably should have done this ahead of time, but I thought starting from vanilla might be
No,
interesting.
it is ritual that every guest has to implement wall avoidance on the stream.
Okay, pull it down. I don't know how you refresh this other than going off of it and coming back on it.
How to make it port? Yeah, there you go.
That seems to work well.
Yep.
Okay, let's see if that works.
Though it's still, you might have to stop and start the server.
Oh, just so it picks up the code?
Yeah.
That's fine. Doesn't take long.
I think, anyway.
Shall we run our snake and see what happens?
Yeah. Let's do it. Searchy's sibling is up.
All right. Oh, I love that scarf.
It looks great moving around live.
Okay.
Okay, so, yep, that's... Oh,
pretty good. We
okay,
hit
went
ourselves.
backwards.
That's okay.
That's fine. Yeah, that wasn't a neck. That was several body pieces down the neck.
And we're not going to fix that today. No, so we're just going to make this snake hungry.
Perfect.
So the way I'm going to do that is we're going to go ahead. Well, the first thing we need to do is we need to add in our library for Algolia.
Is that a pippable thing?
It is a pippable. I think I want to poetry it though because
I don't know what poetry is.
It's a kind of a package manager for Python that essentially that'll get it up into our replit as well.
Nice. Huh. I love it when a language ecosystem introduces a new package manager.
Well, the funny thing about pip is it wasn't really, a package manager in the classic sense, right? Like the concept of having to take like all of your requirements and export them out into pipe them to a requirements.txt file, like definitely was feeling a little old school. So I feel like it's nice to have something that, it gives you this
intended to be that.
Yeah, exactly. It gives you this PyProject TOML file.
Right.
And so this is something that can go right up into Replit, and Replit can pick this up and rebuild from it. So let's see. Should we go ahead? Well, let's go ahead and code a little bit too while we're here.
Sure.
So here's my server logic.
Okay.
So the first thing we need to do, obviously we're using an API here. So we're going to need to initialize a client. And spoiler alert, I already went and put my Algolia credentials into my Replit.
No leaky credentials today.
Yeah. I mean, these are, obviously, like the interesting thing about Algolia is it's obviously a public API, right? You're running this against your search. So we have the concept of sort of secured API keys that are just used for read-only and all of that stuff. But still better just not to show things. That's a good habit to get into. So I've already got those in my Replit, so we should be good there. And so this is all you need to initialize a search client, but we should probably also import our library, right? So that we're actually here above random. So I've got my search client. I'm going to go ahead and initialize that. And now I've got something that I can communicate up to my index. Is it okay to show my index real quick? Should we do that?
Yeah, absolutely. Yeah, for sure.
We keep talking about it, but I haven't actually shown.
Yeah, let's dive into some Algolia.
Yeah, so this is the Algolia dashboard.
I don't know what I expected it to look like, but I just caught sight of an object, and that wasn't what I expected it to look like. Okay.
Yeah, this is the Algolia dashboard. So you can kind of drill down here. You can see we have a concept of applications. That's sort of like our high level. So I've got my Battlesnake application, and then when I drill down in there, we have the concept of indices. And you can see I've got my 3x3 boards and my 5x5 boards. And I even built these wall boards, which have a massive 8 records in them, because it's literally just like, there's a wall there, there's a wall there. But I think this is the most interesting one to us. So this is the index we're going to be going against. Right. And you can see basically what I've done is I've built out just an array that represents a 5x5 grid. So this is 25 characters. Each of those could be an S for food, an S for a space, an O for food, or an H for the head. You can see the head is always in the middle there.
That makes sense. Okay.
So interestingly enough, I originally had the spaces as just dots because it was, more visually appealing. But it turns out that when you have a dot in something that you're going to search against, it can lead to some sort of interesting ideas, especially when we're very opinionated about text search and we are looking for words. And when we see a dot, we get all sorts of confused. So it was just easier to make everything a letter.
Yeah. Right. Okay, cool.
So
I like the representation. That's awesome.
Yep. So say like we've got a board 1, 2, 3, 4, 5.
Yep.
1, 2, 3, 4, 5. 1, 2, head. Oh, I'm using my dots because I forgot. 1, 2, 3, 4, 5. 1, 2, head. 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there we go. That's our fully empty. Or if we want to put one piece of food here, there's our one piece of food board, et cetera, et cetera.
Oh, that's amazing.
Cool. And then for each one of these, I've already added in the best moves and a description for logging, right? So we found some food both to the left and up where we are now.
Sorry if I'm preempting the bit we're going to do after, but like is that best move for when you've run a tree search on it and during some game, or like how did the best move end up in there?
So we can definitely drill into that when I show how we do the boards. Yeah. But basically, as I generate the boards, I pre-weight them all.
Nice.
So every board, after I've generated it, I take it back and I look at the string, evaluate where the food is, and then I put the moves in order based on where they are. So that's based both on the number of items of food in each quadrant,
right,
and the proximity. So if there's one apple that's directly to my right, but there are 5 apples in the upper left, I might want to actually go upper left because I'm going to have access to more apples.
Very cool. Okay. God, that's going to mess you up in Royale mode in a big way. When all of the food is uneaten in the hazard source for a reason. That's awesome.
It's been really interesting to see this logic play out in each of the different battles because, like, one could argue that not trying to get as long as you possibly can might actually be a better strategy for a duel, right? Staying very short and only getting food when you need to might be a better strategy. So it's been interesting to see how this thing kind of plays out. Anyway, okay, so getting back to our code. So now we have the ability to query here. So the first thing we need to do is I need to get my board, the food in my board, into this sort of this string style.
Mm-hmm.
Okay. And so the way I do that is, let me go ahead. Sorry, I'm cheating off of my existing.
You are very welcome to cheat. Do not worry.
Okay.
We've done enough live coding this season. Please bring prior art.
All right. So the way that I do that is I've got a function, and this is, I'm just going to go ahead and bring the shape.
Apple Vision. I love it.
Isn't that great?
Yeah.
Mm-hmm. So you can see basically I'm telling it how wide I want my vision to be, where my head is, and then giving it the board, and then allowing it to kind of go in and build out that string for me. So let me just go ahead and...
I've only just realized that your Python has type declarations. I feel like I maybe haven't seen Python in a really long time. When did Python get type declarations?
Yeah, it's had it for a little while now. I feel like I'm kind of happy that everything's starting to get type declarations. Although I'm really bad at using them everywhere, but I try. Right. I really try to. So I feel like I want to be on the side of typed. That's for sure. So okay, cool. So of course, ironically, I'm also really bad at writing tests. So there's that.
Don't need tests. You've got types. Don't call me in the chat.
Can I get that bumper sticker, please? I could really use that bumper sticker.
Any Haskell can give you one. Don't worry. We carry them around in our pockets.
All right. So let me see. So where I build out let me go ahead and do this. Come on. Where's my choose move? Okay. I'm just looking at my choose move on this one. So the way I build out
cheese move.
Cheese move. The cheesiest. Okay. So let's go.
As ever, chat, I realise we haven't given this warning. If you have any questions at any point, feel free to throw them into the chat, and we will be happy to go on detours.
Absolutely, especially when I'm, stalled out trying to get myself oriented. We'll say my vision equals vision, and we want to do this. We always said 5. I'm going to give it my head, and I give it the board. And then
so what is the 5? Sorry, I should have looked at this when you put the function declaration in. What is the 5 for?
The 5 is going to be the vision size. So you'll see. So as we go through here, basically, build this out. The concept here is that right. We don't want to go. We don't want to go beyond a 5 by 5 right now. Trust me.
Right.
So we're going to keep this at a 5 by 5 for now. I'm going to pre-declare string here. This will be the vision. And then what I need to do is build out the horizontal and vertical ranges here. So, start with X coordinate of where my head is, right? Because I want to be centered around my head. And then I want to make sure that I'm going to before. Oh, wait, I want to go half the size. Sorry, half the size before, and then half the size after. Obviously, we want integers. You can't do partial squares. Cool. And so we'll do that again, and we'll get our vertical range as well. Oh, somehow I lost. Okay, so now we've got the range around our head. And I am just an old school 4 guy. So I'm going to be doing a bunch of 4s here. You can call me out on it.
We support the 4, it's fine. I guess the alternative is
I'm not really
higher
sure.
order functions. Was that what you're thinking of? Mapping?
Yeah, like going through and sort of like something that can just go and identify like all of the. But
right.
I mean, the challenge is, right? You all use a very interesting representation of the board, right? You definitely make it so that it's not sort of a unified thing. You give you all the different pieces, and so kind of going through and grabbing the stuff that you need. It feels like there needs to be, there has to be like some sort of for loops to do these sorts of transformations.
No, that makes sense.
So as you can see, what I'm doing is I'm starting out. I'm calling each of these things kind of a space, and I start out assuming that it's empty. And then what I'm going to do is I'm going to check to see, is this space actually my head? And then the last thing is to check for an apple. I could call them food this time around, I suppose.
Apple works. I mean, I don't know what's on the default game boards right now. Sometimes I don't know if it looks like a pumpkin spice latte at the moment, but I think
it looks like it's gone back to the red circles.
Okay.
But I swear, as soon as I started calling it apple, they were it was coffee, which I love. And it was great.
It was added in for the fall league.
That's awesome. That's brilliant. Yeah, it looks like it's back to red circles for now.
Perfect.
Call me out if it's wrong.
That is the default, so I imagine it has. Let me fire up. Oh, chat, I've got to tell you, I'm so happy that Battlesnake is deployed on Heroku, and now I can just go to a browser tab to make a Battlesnake work to quickly test this. It's just amazing.
Oh, that's cool.
How are we on? How are we doing? Okay, so if you've got an apple, then space equals. Why did you choose O?
But I choose O.
Yeah,
It's round. It's like an apple,
that makes sense. Yeah.
So visually, when I had the spaces as dots, it really just kind of stood out nicely.
Right. Yeah.
So it's not. It was more of a visual reason for doing it. Rather, it's not like O for apple or opful or something like that. It literally like looked like an apple. And so when you printed this out as a grid, you actually got a pretty good representation of what the thing looked like. I guess I could have made my snake head like an S or something like that. So all we're doing here is essentially like I'm iterating through this 5x5, looking for apples. And so then I go through and I check to see if there's an apple at those coordinates, and that's my vision. So now I've got that string. So I can go ahead and actually this should be up here, right? That should work, and we should get a vision string out of that.
Okay.
Okay, and so that is now the... Okay, so now we've got our vision, and so now we've got a string that we can pass into our, essentially, our find moves, right? And the thing here is...
Algolia.
Right. The interesting thing is, the way I kind of handled it is I don't remove things from best moves.
Okay.
I don't remove things from possible moves. I add a new thing called best moves.
Right.
Saying that backwards. So it's not necessarily that you can't go the other directions. It's just that it's sort of preferred to go this direction.
Right. Yeah, that makes sense. We kind of got to that place in the first snake we built on the stream where we ended up, having some kind of risk index that indicated that, like, hey, moves are possible, but you probably shouldn't do them unless you have to.
We'll do this under our little food section here. And again, I'm just going to say best moves equals, and we'll do a function called find board. Now we'll do find food.
Great.
And find food, go look up that one. There it is. Okay, so I'm just going to grab the shape of that one too, just so we can kind of code towards it.
Perfect.
We'll put find food up here. Put it just below Apple Vision. Okay, so again, size of the board. Because remember, I've got indices for a 3x3 board and a 5x5 board.
Right.
So that's going to help us know which index to look in. We're going to pass it that string that we just created, that Apple Vision, and our current list of possible moves.
Right.
Interestingly, earlier, Chuck, why did you think possible moves was important? Well, let's find out. I'm very curious to be. But down here, let's make sure that we've got everything we need. So looking at that same shape, say best moves. So we know we want a 5x5 board. So we're going to use our 5x5 index. And then we want to give it the, what did I just call that? Just vision? Or my vision?
Vision, I think. My vision.
And then the list of possible moves. And now let's build this function out. So this is when we're actually going to go make our call out to our search index.
Perfect.
So I'm going to start with just an empty list of best moves. I'm going to generate my index name, which is essentially, I'm just going to steal this because it's a lot.
Oh, I'm guessing your index doesn't contain position of snake bodies, right? That's probably why you have possible moves.
That could be it.
To then check if the best move is not a possible move.
You're right. That's right. You get a prize.
Woo!
Pass the test of Chuck's bad memory. Okay. So then, so basically all this is just me generating a string, right? I generated my 3x3 boards and my 5x5 boards. And so now we're going to go ahead and tell that search client that we initialized above. I suppose, Look at it, correcting my bad typing. That's great. So we're going to call an index on this and just pass it this index name. Okay, so now we're initialized against the application and this particular 5x5 index.
Okay.
And then I can do a search. And I pass it that string division.
Mm-hmm.
So this is already like the silliest use of Algolia, right? Because I'm passing it like that fully formed string. I'm not looking at the beginning of it. I'm not doing any sort of prefix searching.
You're not trying to get completion or anything.
I don't have to rank the different boards against each other in any way right now.
Right.
Because I'm literally looking for a specific board.
Yeah.
Those are all interesting things that we could do with Algolia, right? Like, it'd be so cool if I could do a partial match and get like a larger board.
What would a partial... What does that even look like?
So the interesting thing about, and I thought about this, the interesting thing about partial match, Algolia uses prefix search, right? Because we're doing as you type. So if you type, it's just like if you're searching for something on Netflix, right? You do you say, I want to watch, I don't know, what was that? Squid Games that was so popular, right? So if I type SQ, well, Netflix knows everyone's looking for Squid Games, so that's enough that I can put that up first.
Sure.
And so that's kind of what we would want. But what would that look like in the world of Battlesnake? And my thought would be like, it would have to be like maybe like a spiral, right? Like instead of starting in the upper left corner, like you start at the snake and kind of work your way out.
So you mean changing the board representation? You wouldn't generate the order of letters would be from the center out. That's fascinating. Okay.
Exactly. So I think a lot of the things that would, much like with the machine learning, I'm sure, a lot of the things that would make the search engine a more powerful tool are around making, exactly, making the data more what it's used to looking across as opposed to what is easy for us to see.
Fascinating.
Mm-hmm. So yeah, and that's basically all it is. So we're going to get our results back. We're going to make sure that our results, we actually get a result. Let's hope that this is a board combination that it knows. And then we can say, should be putting some print statements in here, but I'm just going to write this up, and then we can always put the print statements in later when it doesn't work as we expected it to. The other thing I do here is if I get multiple best moves, if I get multiple, that's right, if I get multiple results back, I'm going to take the first one because the first one should be this board. And then I want to go ahead and grab that best moves attribute. Best move or best moves?
Best move.
Best move, thank you. It's interesting because it's an array. So if move, and this is the thing that you figured out, right? If move is in possible moves, then we say, okay, cool. And add that in, and then we can return our best moves. Okay, and then the last
search portion is very small and easy.
That's it. That's the entirety of the Algolia piece of it. Boom, you're done.
Right.
Okay,
After, of course, you build the index of 16 million things.
After, yeah, exactly. Well, that's the beauty of this, right? Like you do the work ahead of time, and then you just get to serve the cookies.
It's barely even, you're not even really doing logic in the snake because the moves are already very cool.
And so there's a lot of opportunity there to enrich that. And as we look into sort of how I weighted, like I would love to hear some other opinions about like how would you weight that, and like is there a better way to weight it? Because I can simply rerun all the boards and then get there.
Weighting is a constant topic of discussion in the Discord.
Oh, I bet.
So I'm sure there's gonna be different approaches.
Yeah, I mean everything from like machine learning to like human based.
Yeah, there's been some folks running like genetic algorithms to fine tune their weightings recently, which is really cool.
Oh, interesting. So like essentially, if you win or lose,
it adjusts the tuning. Yeah. So like it'll run with different tuning, and then if a snake wins a game with X tuning, the tuning moves towards that thing for the next game.
So Darwinian.
Yeah, very cool.
All right, cool. So let's see. So where do I pick my random move? That's down here in my, right now it's my random move. Okay, got it. So, first thing I'm going to do, we want that to be our fallback, so we'll keep that there. But we want to look for best moves. So we'll say first of all, we'll see if moves or best move in best moves. This is interesting because I've already checked my best moves against my possible moves. So I wonder if this is redundant. Because these should be pre-vetted.
Right.
So I might actually need to do that, but
Where is this happening? Where's the find move code in relation to this?
oh, it's right up here.
Okay.
You see.
Yeah.
Best moves. Yeah, so here we're already saying if move is in possible moves. So I shouldn't need to do that again down here, right? I should be very confident that my move is the best move.
Mm-hmm. Scar tissue, though. Past Chuck did it for a reason.
Exactly. I'm going to keep that for now. I think
it probably doesn't hurt anything, so.
Exactly. Okay, and then I'm going to go ahead and short circuit this and just return that there. Otherwise, I guess maybe I don't want to. We want to show that at the end. Because I was short circuiting it so that
Right.
I didn't have to worry about, do I have move yet? We'll do that though.
Okay.
And then we'll return move. I think I want to show that we picked the best move though.
You think you want to show that we picked the best moves, then?
Like just for my own sanity, I want to know that, we actually grabbed one from here.
Sure.
And then here, say, it's randomly. That way we can at least know that this is somehow working.
One thing I've really enjoyed about watching you do this is how, even though you're doing something completely nonsense that this template was not set up to do, you have still followed the comments in the template and structured your code accordingly.
Hey, I'm nothing if not a rule follower. That's for sure. Maybe I'm a weird interpreter of the rules, but I follow it. Okay. So added search for food should be fine. All right, think this can work all at once? How many errors do you think I have in here?
It can't possibly fail, and the commit says it should be fine.
Should be fine, right?
Should be
The
fine.
commit said it should be fine. Let's see. Wait, this has got to be. Is this my snake?
That
yes.
will still be running.
Stop it. Yeah, we got to pull it in first.
It should really auto. I guess auto pull would be a nightmare, but okay.
Let's see this crash and burn. Okay, what do we crash on?
Oh, it does auto. Okay. Line 7. It imports server logic.
Oh, probably because I got to rebuild and get the
Right.
Algolia search in there.
Yeah, that looks like it.
Let's see if I get Algolia search. There it is.
Whoop, whoop.
Okay, still not quite right. Oh, why didn't it pick it up? Oh, I probably need... There's probably an additional thing I need for pulling in the environment variable.
But it was the app ID that was missing there. Was that one of the ones you imported? I thought you had your...
Yeah, I've got them set up in here.
Oh, you've got
but
it.
I don't think it understands environment. I think there's another Python.
Oh, it will have a weird Replit native one.
Yeah, so let's see here.
Because you've got it in Replit's secret store.
Yes, exactly.
Yeah.
Let's see here.
Some of the built-in Replit things, I really like their like built-in key value Redis budget Redis thing.
Mm-hmm.
It's very fun. Hey Hugh, welcome. Hugh, you should have been here about 15 minutes ago when I realized that Chuck's Python had type signatures. I feel like after last stream, when I wrongly remembered that Python was one index for some reason, I felt like I may have actually never seen Python, even though I'm fairly convinced I have written Python.
Oh, I wonder why it's not picking up the environment variable. Let's see.
Let me have a quick look. There is definitely like a weird Replit syntax.
Yeah, because we do it. So here it's using it for the server port. Port equals 8080.
Oh, I'm sorry, Chuck. Can you go to a function with a nice type signature? Yeah, look at Apple Vision, Hugh. Look at this. It's even got the arrow to the return type. It's almost Haskell type signatures. It's beautiful. Thank you for entertaining me. It's
sure.
os.getenv.
Ah, okay. Actually, can I try? I'm going to try. See if this works.
Oh, apparently oh wait, then you'd have to show us your environment variables. Never mind. I was going to say the Replit sidebar where you've got the environment variables will give you the sample code for it, but then you
that's
the
cool.
environment variables.
Well, no, actually, it doesn't. It's cool.
Oh, okay, cool.
We can go there. Let's go do that.
Yeah.
Rather than beating our heads against this particular wall.
Save with the little lock.
There we go. Add the import. Okay, so we got to import
And
OS.
it's in the little drop down for which one you want.
Pretty cool. Yep, see? And it only shows you the names, so we're okay.
Okay, cool.
So we need to import OS. And then recommended doing it this way. Cool.
Yeah, exactly like TypeScript to you. When are you going to come walk us through your Battlesnake TypeScript wrapper? Welcome, Dota to Attitude. Dota to Attitude has asked Advent of Code. It is not Advent of Code. It is a game called Battlesnake. Battlesnake is a programming game. It's very similar to Advent of Code in that it's kind of like, programming challenge. But you're writing the AI, you're writing the brain for a snake. Think of like, the old mobile phone game of Snake. You've got a snake on a board that eats food and gets bigger, etc. You're writing the code that controls that snake, and then it's multiplayer. So Chuck is it's what we're doing right now is very loosely pair programming. It's mostly me being in awe at what Chuck is doing. Chuck is writing a snake that uses Algolia, which is a search service, to use a search index for its brain rather than how we would traditionally write Battlesnake. Dota to Attitude, if this is your first time seeing Battlesnake, this is going to be real weird. But welcome, we're so glad you're here.
Yeah, I'm definitely a little bit outside the box. Okay, let's see if this picks these variables now.
Fingers crossed.
Yeah. Looks like it likes it.
Nice. Awesome.
Hey, Joe, if we're talking about coding contests, do you mind if I mention something real quick?
Oh, yeah, we spoke about Advent of Code. We said the code word. Yeah.
Yeah.
Algolia has a coding as a seasonal challenge.
Yeah, if you're someone who really likes going in and kind of digging in on coding challenges, we're actually at Algolia, we're running a very simple coding challenge. It's Santa themed, it's that time of year. And the concept here is that Santa is getting a little cooped up and needs a little bit of inspiration. And so we're giving you 5 challenges, basically to use data sources that we provide, along with Algolia, using a free tier account, to go ahead and try and answer these questions. So you could try and answer these questions yourself. Like, for instance, you might be able to figure out which Star Trek actor gave a TED Talk that was very inspirational. But it's a lot easier to do just by building an Algolia UI. And I will warn you, it is a show your work style contest. So we do actually want to see that you actually built an Algolia interface. But if you're interested in playing along, there is a form here in this Algolia blog post that you can fill in. And we'll give you access to a Discord server where you can chat with other folks. The cool thing we're doing for others is we're donating to Hack Your Future for every participant that successfully gets the questions right. Awesome. And then for yourself, we're giving away a phone. So kind of fun. Cool.
Neat. So, I've dropped the link to that in chat, which was a pain to find. I did not realize that Algolia do so many coding challenges.
I should have said that to you ahead of time. I apologize.
No, you're all good. We spoke about it. I forgot to ask about it. That is awesome. I'm really liking this theme of everyone does December themed coding challenges. That's awesome.
Yeah, it feels like it's that time of year, right? We kind of everyone gets a little loose and goofy.
Right.
Let's see. Let's see if this person.
Dota Attitude. It can be a machine learning thing. You can write your Battlesnake brain basically however you want. So some folks use machine learning. Some folks just do good old fashioned if statements. Some use various other algorithms. What Chuck is doing is using an API to a search index. There's loads of different approaches to it, and that's kind of why the game is fun. No matter what kind of programming you're into, there's probably a way to write your Battlesnake that kind of does the thing. Python does seem very machine learning-y. It's very popular in the machine learning and data science sphere. That's probably why. Did the snake work? Oh, you haven't committed. Okay.
Well, so it told me that I was trying to slice an array using an integer because I had quotes around my 0. Because I apparently got a little quote happy.
Got you.
Give this one more try here. But we got past the other thing.
Right.
Let's see if we can start this up again. Oh, that's right. I got to do this first. I probably could have made that change right in Replit, but I'm trying to be a good programmer and use my repos appropriately. Okay, let's try and run that again.
He's committing when the blue editor is VS Code. That's the local editor, and the reason Chuck is committing is because we're using Replit, which is a cloud environment. So the code has to be committed to get up into Replit. So he's committing whenever we want to go to Replit.
Yeah, and there's probably an easier way to get from one to the other. And also, I could make the changes right here in Replit, and Replit will actually allow me to do commits the other direction into the repo. But again, I was just trying to be, trying to follow my flow there and not be coding in 2 places at once.
And also, committing regularly is good practice anyway.
Okay, so I'm going to go ahead and start a game here. This is my Chuck Codes Battlesnake. We're doing an 11 by 11 board, and let's see what this does. Okay, it looks like it's not happy. So what are we doing here?
Local variable move reference before assignment.
Okay. Right there. I'm sure that's it.
Yeah.
Let me check that against. I'm gonna cheat again. I'm gonna look at my.
But it's 4 move-in results, right? So that doesn't create it's assigned by the for loop there.
Right. So let's see.
New is a very subjective thing when you're talking about Python Dota Attitude, because Python 3 was 2008. So new.
Here we go. If not move. Let's see where that is.
1P Flores is here. Thank you so much for joining us. Yeah, one. So you're here at the end of the Coding Badly season, and we bookend the Coding Badly season with people who know what they're doing. So we're joined by Chuck today. So the code is good today.
For certain values of know what they're doing. So
Yes.
this is where it's causing the problem, right? Because I hadn't predefined my move here, and
I
we
see.
must have finally gotten to one where there wasn't a best move,
Got you.
but it wasn't blink.
Got you.
So there we go. Let's see if that solves our problem.
So Wampa, what we're doing today, thank you for joining us. We are seeing a Battlesnake built using Algolia. So it's using an Algolia search index to decide on its move, which is the kind of mad genius stuff that we like here on Coding Badly. Wampa, if you want to come do a Copilot Snake, Copilot? It's called Copilot.
Ooh,
It's,
yeah,
you're very
Copilot.
welcome to.
Oh man, what is the opinion of the most common shape of a snake? That would be amazing to see. All right, let me go ahead and.
Oh, don't worry, Wampa. I didn't mean this week. We are. It's the end of the year. We are winding up. Don't worry. I'm not asking you to come on like immediately. It'll be next year. Next year.
Okay, let's give this another try.
I'm sorry
here.
to hear you've got a cold, though. I hope you recover quickly. How's it doing? Am I in Australia? No, no one's in Australia. I'm in the Netherlands, but I'm British, which is probably why you think I'm Australian. And Chuck is in Ohio.
That's right. Okay, we'll do this one last time. Please, 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 because I know we've got other things we want to talk about and not a lot of time left.
It's all good. We believe in the snake. It's working.
There we go. There we go. Let's watch him. Or, I'm sorry. Yeah, is this a him or her? It's a they. This is a they.
It's a day now. Yeah.
There we go. And it found that food. And it found that food. Oh, it didn't find that food. Interesting.
Oh, and then it went wrong.
Yeah.
Fascinating.
Picking randomly
do you
every
print
time.
your whole? Okay, so it's not getting the best moves.
Yeah, it's not finding the best moves. We should print those out.
Yeah. So in this case, Dota, the code we're writing drives the snake. So the snake game, we haven't coded that snake game you just saw. That's the game. What we're doing is writing the code that controls the snake. Wampa, that would be awesome. There's actually a feature now in Battlesnake where you can choose your engine region. So you can choose a server that's like closest to you geographically. So the performance should be a little bit better for LATAM, as well as now it actually is possible to play in Australia and Europe.
Wait.
So yeah.
There. Let's see if we're actually getting anything in there. Closing there.
It wouldn't be live coding in general if there wasn't some mystery bug.
No, it's so weird. Why is it's just always picking random still?
I was pre-recording a workshop for.
I'm just gonna do this here.
Okay. I was pre-recording a workshop for work the other day, and I got to that point like 4 restarts in where I was like, "Sod it, I'm just gonna leave the errors in there." And so there's like a wonderful section halfway through this workshop where I spend 5 minutes looking for a typo. Just typical.
All right. I mean, since we're just putting in,
You just
print
console
statements now,
moves, right? Yeah.
I'm just gonna go ahead and do that, and then we'll go ahead and run it. Create a rematch. Let's see what happens now. Yeah. So we're not getting any best moves.
Huh. So they're
Oh
just
wait,
not
there's some
coming up.
best moves. Yeah, we're getting best moves, but why are they not getting in?
And they're also very sporadic.
Well, that makes sense. It's a 5 by
Okay.
5, so it would only be when we get close to an apple.
Right. So something wrong with the looping logic. So
Yeah, I think it's that little chunk of code where I'm trying to, the scar tissue code, right? I feel like this is where I'm somehow not picking up the best move, because let me go back to Replit, and if we look here, best move is up, but we picked a random move. So I think this code that's trying to just put a lot of guardrails on it is too much. So I'm just going to take this up a layer and say that if there are best moves,
And then 4 best moves and best moves.
yeah. Although I don't know why possible moves would break that.
Oh, hang on.
Mm-hmm.
That line. If best moves in possible moves, it should be best move, right?
Oh! Look at that. Joe, well done. Oh my gosh. That's it. That's it. I'm just going to change that here. I've been so good up till now, but I can't help myself. I'm just going to change it.
one straight S.
One stray S. And the fact that I changed it there and didn't commit it means it's going to bite me again.
Oh no.
Next time I show someone this, right? Okay, let's see if that works better.
There we go.
There
Pick
we
his
go.
best move.
Okay, let's watch that one.
Oh, look at that. Oh, it's
there we
so
go.
greedy. It's so greedy.
Oh, yeah.
Oh, that was really nice how it started going towards the bottom and then a nearer food appeared.
Yep.
Oh, I see what you're saying about the food grouping there. That was like how it was closer to that top food and it went for the food nearer to the middle of the board.
Yeah, and that's a great sort of segue in if we want to talk a little bit briefly about waiting before.
Yeah,
we wrap
absolutely.
it
I'd
up?
love to do that. Yeah.
Okay. But there we go.
Yeah, waiting.
Can we celebrate?
Perfect.
Yeah.
So let's recap that. So you've taken the Python starter, integrated Algolia, and if you throw up the Algolia bit again. So the Algolia bit, like the actual finding going into your search index is like tiny. There we go. And so key point being here, if you wanted to build a snake-like searchy, here's how you go and get your index. And then all the fun, I guess, is in how you build that index, right? And what you use the index for.
Right.
And as you said, the weighting and how it decides on the moves.
I'm going to bring over, this is actual Searchy. So this is Searchy's folder. And you can see the difference here is in Searchy, I've got these utility functions.
Right.
And these utility functions is how I actually go and build those boards. And I do it in a couple of different parts. So there's this lovely, let me see, big board. So basically everything's kind of pseudo object oriented here. So I've got a concept of a board, a concept of an Algolia index, and a concept of a play. So the first thing I do is I generate these boards. The core function here, I tell it the board size that I want, defaults to 3. And that's the side of a board. So if I give it a 5, then it's a 5 by 5, 25 squares. Then it calls this lovely recursive function here.
Right.
And this is the thing that I iterated on for a very long time. But the bottom line is,
what's going on here?
Yeah. So there's all sorts of sort of interesting sort of optimizations that occur in here. But basically, at the end of the day, I go through and I iterate along, and I create an initial board, and then I start adding boards for every combination of apples, right? So first I go and I generate some apples. I add an apple to the board, and then I go ahead and build it. But I start at the bottom and work my way up. So basically what this does is it starts at a full board. You can see like if you actually look at the index, the very first one that comes up, if I clear this out, should be a full board. Come on. Yep.
For
an empty
Q
board.
and
It's an empty
Dota, the strings in that search index are
yeah.
representation of the board. Sorry, we had new viewers coming halfway through. So S means it's an empty space, H means head, and O means it's a food object. So this is just converting the food JSON into a string.
Right. That is appealing to my search index.
Yes.
And so basically I'm just kind of drilling down through here, and I'm building, more and more iterations of sort of various amounts of apples, and then creating a board for each of them. And the first thing that I had realized here is that I needed to use a set for my boards, because the difference between a set and a list in Python is significant as far as when you're dealing with keep in mind that we're talking about a set that's going to get up to about 16.7 million. And so at those levels, the amount of drag that you start to get as you start to go in and sort of add additional boards was significant, particularly because one of the things I do is I validate that I haven't seen a combination of apples before. And so what this allows me to do is, keeping in mind that I'm navigating horizontally and I'm also navigating vertically. So like think about like you've got an apple at 0,
Mhm.
0. Then you've got an apple at 0, 1. Well, then I'm going to come back and say, okay, I've got an apple at 0, 1. I'm going to add one at 0, 0.
Right.
Like, I've already seen that one. So I need to make sure that I'm pruning all of those branches that I don't need. So that's definitely something I'm doing here, is recognizing, oh, that's a pattern I've seen before. Skip it and skip all of the children of that one too.
Right.
And so that saved me a significant amount of time, particularly when I switched to sets, because it made it super easy to kind of check those patterns against each other.
Right. What is the... Sorry, this might be getting you too in the weeds. What is the... What are Python lists? Are they... What's the, like, big O properties of accessing Python lists?
That is a really...
I assume they're going to be singly linked, and so it's going to be ridiculous.
Yeah, it definitely, it felt exponential as I really started to go into it, but I don't know what the underlying implementation is. I can't actually tell you right now. So it definitely, but I can tell you that moving to a set...
That sets were better,
Sets were better, definitely better. The other thing that significantly sped this up is recognizing that because I was doing every board combination and it was binary, for every board there was an inverse board. And so one thing that I do here is, rather than iterating through all of those as well, I just simply, every time I encounter a new board, I add the inverse of that board as well. So that halves the number of times I have to go through my recursion.
That's awesome. Very nice. And there's still... So for the full board states, how long was this taking to generate? For all 16 million odd?
It was taking, I think on my M1, it was taking about 2.5 hours.
That's not terrible.
Yeah. So, and that, I mean, that's coming down from, like, I left it run overnight and came back and was like, oh, you know, when I was using lists and didn't have the inversion and stuff like that, it was significantly slower. Honestly, like, between the building the inverse board, which you know obviously only works because this is binary, I'm only looking at apples, but it halves the number you have to do. It's a huge boon there.
Yeah.
So that's pretty much it for this. There's not really a lot else to it. I've got some debug stuff. The inverter is just this, right? And yeah, that's everything. So once I have the boards generated, then I go and I pass them to my weighting algorithm, which is I call food plays.
Cool.
And so this is the weighting. This is just kind of fairly arbitrary on my part. But basically, I'm doing a combination of, did I see an apple and how close is it to my head?
Yeah. This is what's really interesting about this, is like, even if you took exactly Searchy's code as it is now, generated, there's like a million things to change about this, but even if you generated the states in the exact same states, exact same working on states, just like simple changes to this would result in a totally different snake. Which is just, I mean, A, super interesting with how these algorithms work, but B, I like the way you've divided this up. It gives people a lot of scope to play with the concept of search snakes in like fun ways.
Oh yeah. And
so sorry, you go ahead.
The interesting thing is, like, so for me, like, it's just this matter of, like, I do this proximity, right? So, and again, because I've got everything in a string, like, I'm essentially just using some silly math to essentially look at proximity based on the fact that everything's a string with the head in the middle, and then weighting appropriately.
God, yeah. Huh.
So now, obviously, if we change to, we were talking earlier about, like, are there ways that we could leverage the fact that Algolia uses prefix first search? You know, and perhaps we could, like, build the board in a different style, like a spiral or something like that. Obviously, that would change a lot of this sort of proximity stuff, but there's obviously a similar way that you could do it.
And, you know, even as you were saying earlier, like, you don't necessarily want to always be, like, optimally greedy. Just, like, you know, as you said, like, the behavior right now is it prioritizes, like, groups of food, even just, like, stepping that off a bit. Very cool.
Yep. And so this is sort of the meat of the weighting. And once I have that, I go ahead and inject all of that in, and I use that to build my little board object here. So each of my objects, I have those best moves in there. I have a description for each of them. You can see that in here, so that if you're doing, like, you know, if you're doing troubleshooting or you're trying to kind of, like, look at what decisions your snake is making,
why the best moves were, what they were.
Something human readable right there.
Cool.
And, you know, obviously, so what I'm doing for my snake, this is the only thing that I'm using search for, is the search for food. My snake avoidance is all hard-coded logic. I could
Right.
show that. It's not.
And that's right now just like stay away from all snakes, right?
It's like stay away from all snakes, and especially stay away from heads, because heads are tricky.
Right.
Which I that was the piece that like made a big difference when I started
Yeah.
doing duels, was like that whole like, oh yeah, like one away if it's the body, but if it's the head,
Yeah.
just
You
stay
don't want to
far
get
away.
into that typical like you're both at diagonals, and so you've got the 50-50 coin flip game to play. Yeah.
Right. Are you playing chicken or not? So I chicken out every time.
Yeah. Which is a smart choice.
So, well, I would love to build a version of this that was a little smarter about how it handled other snakes, because I think there's an opportunity to build like a really cool dueling snake.
I guess there's no way, even just adding single, like other head tracking into the board states is gonna. Oop, we lost Chuck. Hello, everyone. I lost our guest. I'm sure he'll be back in a moment. In the meantime, let's thank our lovely partners again. Thank you, RBC, AWS, and GitHub, for making what we do possible. If you have enjoyed the streams here on Battlesnake Official on Thursdays and Saturdays, make sure you let them know. If you're participating in any of our leagues, make sure you let them know. And this Saturday, we do, of course, have the Winter Classic Invitational, where Battlesnake gets a bit of esports. We have Chuck back. Welcome back, Chuck. What did you refresh?
Remember when our Google Chrome told me it was going to reboot an hour?
Oh, I forgot. Damn, we missed it.
It meant it. It actually
Yeah.
meant it. They were serious.
Dot on the 23 as well.
Yeah.
For those of you who have
Sorry
no idea
about
what we're talking about, yeah, Chuck's Google Chrome warned him it was going to restart an hour ago.
It absolutely did. So sorry about
Can't
that.
believe
I
it.
Didn't mean to do that. I blame the enforcement folks at Algolia.
It's very funny. It's the first time I've ever seen anything like that. That is amazing.
Mm-hmm. I was wondering what happened myself. So
Yeah.
So we were talking about avoidance. You were saying
Yes,
amazing.
we've lost your screen share.
Yeah. Oh, let me send that back up.
No, Royal Bank of Canada is in Canada. I'm in the Netherlands, Dota, but Battlesnake is based out of Victoria, BC, in Canada. There you go.
Cool. So yeah, so this is my silly avoid snake logic, but I think you were going to say something about like maybe possibilities with search.
Oh yeah. So like adding even another generating just another snake's head in the board states would just explode it to ridiculous proportions, right? Like,
well, there is a approach that I was thinking of taking, and this is just me being even more insane. Is if you look at, let's see, of course everything's reloaded, but if you look at Searchy's this is Chuck codes badly, but whatever, it'll be the same. Oh shoot, we lost my latency numbers. Anyway, the latency that I'm getting is about under 250 milliseconds.
I think if you press play again, it should just press the play on the board.
Will it show latency? Oh, cool.
Yeah.
So I'm not getting my access for some reason. I don't know what happened.
Badly rendering, but yeah, it was that the baseline was like 300 basically, so it was like popping just above 300.
Yeah. So I could theoretically build another index around obstacles, where obstacles is other snakes, walls, and hazard, right? And essentially kind of like do a 2-query version. Silly,
right?
But essentially have two different visions. I have my avoidance vision and my appealing vision. Yeah,
that'd be interesting. I mean, I said you've got the headroom. It would be interesting to get an idea of actually like how much the round trip to Algolia even contributes to that. And also, again, you're running it on, I don't know if are you on premium or free Replit. You're running it on Replit right now. Like if latency became an issue, AWS would resolve that.
Yeah, that's true.
Yeah.
That's true too. Yeah, the Algolia searches themselves. You can see if I do a, let's see, let's just search for, grab this board out of here. Do a search on that. Now this obviously is from the dashboard, but you can see I'm getting 5 milliseconds.
Yeah.
So that, there's a little bit of overhead for like the API,
the network
and
back
all
and
that
forth.
stuff.
Yeah.
But yeah, I think there's probably
lot,
enough room if
basically.
I wanted to do if I wanted to do multiple queries and get crazy with it.
Yeah. Amazing.
And then the other thing that I'd thought about doing, and I put some of these ideas in the README, was to, is this my README? Yeah.
Yes, it is. Yeah.
Was to do something potentially with geo.
Yes.
Where, because the other thing that Algolia does is we do excellent text search, but we also have concepts of like geolocation search. And one of my colleagues was saying, the board is just a geography. Like you could essentially assign
a coordinate space. Why not?
Yeah, you could essentially assign coordinates to it, and then do a search based on like bounding boxes or something like that. So there's one of my colleagues did an amazing thing where he was doing color recommendations by essentially treating colors as a map, and then proximity. So like if you were say burnt umber, you were close to orange, and then it would make it easier to sort of find other things. So there's some interesting things I feel like you could potentially do with that.
Yeah. I'm trying to. You'd still. I feel like that would be really nice for avoiding that. But again, you'd have to add bodies to the to the states in the search index. But that would be really nice for like a really common problem for like heuristic driven snakes is, detecting whether they've entered a loop of their own body.
Yes, exactly.
And if you used, actually, no, you wouldn't have to. You wouldn't have to add bodies to the states. So what you could do is use your snake's body segments as the bounding box of the geo area, and then just search, and then just use that to check, again, 5x5 is not going to be super useful for that, but you can then use that to check an area. Does that make sense? But yeah, that's really interesting. There's definitely some fun things you could do with that.
Yeah, and I mean, I wonder if even when you start talking about obstacles, if there's an opportunity to project that square out.
Right.
Like if I'm going left rather than having it centered on my head, project that out to the left of my head.
Move the 5x5, yeah.
So you get a little bit more vision that way, right?
Yeah.
So there's some, I haven't quite put I haven't gotten to something that makes me I want to pursue it next. But I think there's some interesting
that's also a good use for, as you said, like the researching, right? Like if you've got, you've got a whole search index of 5x5s. If you've got extra time, just search all the 5x5 spaces, just as a tile set.
Literally,
literally
type ahead. For board decisions.
Yeah. But it's I don't know how you then link up the best moves, but it'd
be interesting. But and then, I mean, that's definitely starting to get a little closer to what Algolia is great at, right? Is just is okay, what about this? What about this? What about this?
Yeah.
So
awesome. Well, thank you so much for joining us and running us through how Searchy works, how Algolia works with Searchy, how your board state generation is working, and some of the things you're thinking about. This has been definitely a very appropriate wrap to this year's Coding Badly. Just to run off a couple of things that we have mentioned during the show as a summary, things I've forgotten about. We have the blog post about Searchy and how it is built. I will drop that in chat again. We have the Algolia Coding Challenge running. When does that end?
That ends on December 19th. So you've got some time.
December 19th. Yeah, still got 10 days to get that in. The GitHub repo itself for Searchy. And then, did you have the blog post about the geo search?
Oh, yeah.
Was that your colleague's blog post? We spoke about that. Is that the color space one?
That's the one that I was sending was actually around. It's using the Johns Hopkins COVID data.
Oh, nice. Okay, cool.
So, and it's essentially showing, COVID cases based on geography. So, I'll drop that in for you, and then maybe you can share it with our friends.
Awesome. Perfect. And if people on the internet want to find you and you want to be found, where can that happen?
So I am Chuck M over on the Twitters, so you can find me there, and I'm also chuck.meyer@algolia.com.
Perfect. Well, thank you so much.
And maybe one more shout out too because you mentioned doc search earlier. So if you are involved in an open source project and you're interested in adding search to your documentation or your blog, check out doc search as well.
Yep. I can definitely vouch for that. I've used it for open source project. If you just joined us, that's the context which it came up earlier. I used it for some internal developer docs, and it was delightful. So I can highly recommend it. Well, thank you again so much, Chuck. I will slide you off screen and do the outro stuff, but it's been a pleasure seeing Searchy today, and enjoy the rest of your day.
Thanks. Bye, everyone.
Alrighty, thank you again, Chuck. That was awesome. All the links, definitely check out the blog post on the write-up of Searchy and how Searchy works. If you were just joining us, again, this is, as I said, we bookend the season with snakes that are actually unironically good. Searchy is gold in jewels. Like, Searchy, this approach has merit. Like, this is not stupid. It's very... The second time this coding badly, we're like, we've had a stupid hack on that has actually turned out to be good this season. So thank you, Chuck, for walking us through that and how we can implement that ourselves straight out of the Python starter snake. So again, final mentions for me. Thank you to our partners, obviously AWS GitHub, and most importantly, Saturday is the Winter Classic Invitational Platinum League. If you do not know what any of those words I just said meant, Battlesnake has seasonally leagues. This winter, we are doing our first ever invitational. What does that mean? It means that we have invited the top snakes from the leagues of the year, the top performing snakes, the best competitors, and there is some prize money up for grabs. It is a competition with cash prizes. Invite the top snakes, and there is 2 tournaments happening this weekend. It's the Platinum tournament on Saturday on Snake Pit Live, and then next weekend it is the Elite, I don't know what it's called. It is the one above Platinum tournament the following weekend. So it is a pod of fantastic snakes. It's going to be fantastic viewing. It will be with the usual casting crew, which is always a good time. Saturday at a time. Let me go to the event thing right now and tell you when exactly it is. It is gonna be at... That's in my time, which isn't useful. It's going to be 7 p.m. European time. That is 6 p.m. UTC, or it is 1 p.m. 10 a.m. Pacific. So 10 a.m. Pacific, 6 p.m. UTC, 7 p.m. CET, Saturday, Winter Invitational Tournament. It will be absolutely wonderful. And then we wrap up this year's Battlesnake content the following weekend with the Elite Tournament. Do not miss it. I don't know what's happening next year. We'll be back. Tournaments will be back. But for now, that is all the Battlesnake you get. So make sure you do not miss that. And again, thank you to Chuck. Thank you to everyone for watching Coding Badly this season. I'm going to see us out with our wonderful teaser video. And I will see you on Saturday and then the new year. Bye.